Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 11 of the December daily Leetcode challenge. Yesterday we had a very good question which was of the FANG level question. Okay, I can say that was having the caliber to be a FANG level question. Okay, so if you have not done that, please go and check out the day 10 December daily Leetcode challenge question. That is yesterday's question. I've given you a lot of explanation that, and I've given you something, okay, which is even and above what Leetcode has given. Okay, so I've given OF and solution for that. You can just go and check that out. I've upload part 1 part 2 video of that was something really nice. That's why I don't want you to miss that. Please go and check that out. And coming to this question is again going to teach you a new algorithm. Basically, this if you remember, if you have been following LeetCode for a long time, okay, I guess after, around 2 weeks back, we had a bi-weekly challenge in that the similar question came for the same algorithm. So if you have given that contest and if you have upsolved, that is, if you have learned the solution for that question, this question will be very easy for you. Okay, let me tell you that again, like if you have not done that, no problem, I will teach you that again. So basically this refers to a new algorithm. You have to learn the algorithm. After that you will be able to do any question of this kind. Okay, we'll come to that also. So to begin with, I'll show you the proof of solution and then we'll go for the optimal solution for this. So let's begin this question today. It's 2779 maximum beauty of an array after applying operations. Okay, so basically what we are given is here, you're basically given a nums array and a value k. Okay, so these are the only two inputs and you have written integer as the output. So let us quickly understand what is happening. So see, what they're trying to tell you is that each see, there is optional. Okay, like for example, for each element in this nums you can apply operation. Okay, only one operation you can apply for each element. Okay, simple as that. That is, it's optional. Remember, that's optional. You may apply, you may not apply, but remember, only once you can apply for each element, or you can say for each index. So what is the operation? The operation is that take the element. Okay, you can replace this element, okay, with any element which is in the range 4 minus 2 and 4 plus 2. That is the number itself. That is, let us say I'm talking about 4, so this can be replaced with 4 minus 2. Where from 2 is coming? 2 is coming because this is the one. Okay, so what you can do is, okay, let me tell you this very frankly. So let us say the value is nums of I. Okay, the value is nums of I. So this particular value can be replaced with either, okay, so let me copy this. Okay, it can be replaced either from nums of I, from minus k till this nums of I and plus k. Okay, so this is going to be the pattern and this you have to do. Okay, for each integer, this, that is, yeah, for each value in this nums, this is the possibility. You may do this, you may need not do so. Okay, that is up to you. This is optional thing. Okay, you can do that, you cannot do that. After that, what you have to do is, they are saying return the maximum possible beauty of the nums array after applying the operation any number of times. But remember, for each index you can apply that only once. Okay, that is the question basically. And that beauty they are defining as, the beauty of array is the length of the longest subsequence consisting of equal elements. So see, that is just a tricky way of telling you this. This doesn't make sense here, because let me tell you this. What I've highlighted current on the screen, it means that you have to basically return the element which is there with the highest frequency. Okay, that is what they're trying to tell you. That is just there is a tricky way of telling this, but this is going to be the thing. Okay, for example, we'll see the example one now. So see, let us say this is going to be our final output. In this case, if you see, the number 4 is basically appearing for 3 times. That is, the number with the highest frequency is the yeah, any number which has the highest frequency in this is 3. Okay, that is, the number 4 is appearing for 3 times, so the highest frequency here is 3. Okay, 3 is going to be the answer. Okay, so that is what you have to ensure. I will again repeat. After applying all these operations, we'll go to the detail of it now, but just I'm trying to explain the question, because I don't want to go the way they have defined it, because it doesn't make much sense here to waste this much time just understanding this simple question. Okay, so see here, just apply the operations. For each one you can apply operation only once, and it is optional. Okay, you need not apply also. Okay, that is the basic idea. After that, let us say you are getting this kind of array after applying the operations. Now what you have to do is, you have to return the max frequency that is appearing here. Okay, here the max frequency is for 4. Okay, the 4 is appearing for 3 times, so the answer is going to be 3. Okay, that is what you have to do. The way they are trying to tell you that, return the max possible beauty of the array nums after applying the operations. Okay, what is beauty? Beauty is of array is the length of the longest subsequence consisting of equal elements. So this is nothing but the highest frequency item that is appearing in the array. Okay, so we have to return, after applying all the operations, the element which has the highest frequency. Okay, let us quickly deal about example one. So see here, I have done this calculations here already. So see, you are given this particular array. Okay, so this is the nums array and this is the k value. Now what you can do is, see, for 4, what is the range going to be? 4, it is going to be, 4 can be replaced with any number between 4 minus 2 till 4 plus 2. What is that range? It is going to be from 2 till 6. You can take any number in this range and replace 4 with that. Okay, that is the basic idea. Now come to 6. So what is the range for this? It is going to be 6 minus 2 till 6 plus 2. So what is the range going to be? It is going to be from 4 till 8. Okay, now come to 1. For 1, what is going to be the range? It's going to be 1 minus 2 till 1 plus 2. Okay, that is minus 1 till 3 and so on. Okay, for the last element 2, what is the range? It is going to be 2 minus 2 till 2 plus 2. Okay, that is 0 to 4 and so on. Okay, like that. And because, yeah, there are no more elements, so that this is what it is. So now what to do is, for each number here we have to basically replace them with one of the ranges for there. Okay, for example, for 6 I have to replace with a number in this range. Okay, so let us see the way they have done it. So they are replacing it 4. So in this range what they're selecting is 4. Okay, the one they are selecting in this range is 4. Okay, in this range again they are selecting 4. In this range again they are selecting 4. Okay, for the number 1 they're not selecting anything, that is they're leaving it as it is. So let me write it back to 1. Okay, so if you see, the number 4 got converted to 4 finally, the number 6 got converted to 4 finally, the number 2 got converted to 4 finally. So the number 4 is appearing for 3 times, that is the highest frequency here for any item is 3. So you have to return 3 as your answer. So ultimately this is the question, right? So we will quickly try to understand the brute force approach. Yeah, just this is the ultimate summary of this question. Each number has to be replaced with a range, with any number in this particular range, that is nums5 minus k till nums5 plus k. Okay, this is the question. I have spent a lot of time in explaining the question to you. I hope you understand the question now. And now if you see the constraints, the nums array in search is given as a positive one. Remember that is each number in the input is going to be positive. But remember, since we are also doing minus k, remember here minus k is also being done. So this will ultimately lead the output to have negative numbers. Okay, so k is going to be up to 10 power 5, and similarly the number of elements you are going to have is also 10 power 5. Okay, so this is the question. Let us see the brute force solution for this first. Okay, so let me comment out this part quickly. We'll just quickly understand the brute force solution and then we'll go for the optimal solution. Remember, without understanding this brute force solution, you will not be able to appreciate the optimal solution. Okay, so what I'm doing, let me show you the output first. Okay, so what you're doing is I'm going through each element. Okay, let me zoom in. I'm going to use a map. You can also call it as a frequency map. For basically what it is do is, for each number you're storing its frequency. Okay, as simple as that. I'm going through each number. Okay, then I'm going through each number in the range, that is c. I is the number. This I need to replace with a number in this range. Okay, that is, see, this 4 will be replaced with a number in this range. So I'm just going into this range. Okay, I'm just going into this range now, from I minus k till I plus k. Okay, plus one. Why I'm doing plus one? Because in Python you have to add plus one to ensure that the last element is also included in the range. Okay, fine. Now since this, that is, all the elements in this range have a possibility, right? All of them have a possibility to appear. Okay, for them, what I will, for each of them I will update the frequency by one. Okay, I will add one to their frequency. Okay, I will, what I'm doing, I'm just doing a plus one to the frequency. I'm incrementing the frequency by one for each number in this range. Similarly I will do for the second element. So each number in this range I'm incrementing the frequency by one. Similarly here, for each number in this range I'm going to increment the frequency by one, and same here. Okay, so at last what you will see, for all of them, I'm incrementing the frequency by one. I'm printing the output. Okay, let me show you the output first, then it will make more sense to you. So see, this is how the output is appearing. And this is, let me go to example one first. Yeah, so if you see example one, yeah, so you can see that the number 2 has it can come for 3, that is, yeah, number 2 has the possibility to appear for 3 times. Similarly, the number 3 can appear for 3 times, the number 4 can appear for 3 times. This is what actually we saw in the example given by LeetCode. Okay, ultimately they are converting to something, a number 4 for 3 times. Okay, so this is where it is coming from. Okay, similarly the number 5 can appear for 2 times, and so on. Okay, and so on and so forth. So what is important to her is, here is, which is the highest frequency for any item. Okay, I am not bothered about which number is appearing for most time. Okay, that is not a concern to me. My concern is what is the max frequency. So here I can see 3 is going to the max frequency, so the answer is going to be 3. Okay, that is what we have to ensure. Okay, so if you see here what I am returning the max value among the, that is, among the values I'm returning the max. Okay, I'm not bothered about what are the keys in this particular mapping. Remember, A is a mapping. What it will store, this will store the frequency, that is, it will store the number and its frequency. So the key is going to be the number, its value is going to be the frequency. So among the frequencies, which is the maximum value that we have to return. Okay, that is what I'm returning here, basically. Okay, so yep, that was all about it. And yeah, so if you segment this, this will clear almost 95% of the test cases, but it will fail after that. Okay, because the time limit exceed error will come. Because if you see the range, it is going to 10 power 5. Okay, k is also in the range of 10 power 5. For that reason it is too high for it to do that. Okay, in the next solution that we are going to see, basically we are trying to learn about the line sweep algorithm. Okay, let us try to understand this now. Okay, so in the previous algorithm, what difficulty that we are facing is that, see, for each range, in this each range, I go to each element and then I have to update their frequencies by one. So that is a very time consuming operation. If, especially if you consider the values of k, right? This can be on the 10 power 5. So when you do a minus of 10 power 5, you know see the limit here. See, it is going to be from 0 till 25. So let us say 0 is present and I'm doing a minus 10 power 5. So actually it is going to be from minus 10 power 5 till positive 10 power 5. So definitely it's going to take a lot of time. For that reason, we are trying to use a algorithm called the sweep algorithm. Remember, it's very, very important algorithm whenever you're dealing with a range of frequencies. Okay, when we're dealing with a range. So let us try to understand this algorithm here. So let me zoom in. Let's quickly begin. Okay. So first I will show you example and then we'll use the algorithm. So this is basically, I'm creating a frequency map here. What will happen is, see, this particular frequency is for number 0, this particular frequency is for number 1. That is what I've written below. That is going to be the number for which this particular number is representing the frequency. Okay, this frequency is for number 2, this frequency for number 3, and so on. Okay, so initially all of them are 0. Fine. Now what we have to do, we are getting a range. Okay, let us say this is our range in my question. So in this range, whatever numbers are coming, for all of them I have to go and append their frequencies by 1. So how it will look, this will look something like this. Okay, so for 1, 2, and 3, what I have to do, I have to go and append their frequencies by 1. Okay, fine. But we will try to do this in optimal way. Remember, it's optimal in the sense, when we have a lot of queries, we have to do something so that we are not repeating things, right? So that we will have to see how this sweep algorithm works. So what it will do, it will go to index 1 and it will append 1 there. Okay, now what normally we should do, we should append 1 to all of these, right? For all the numbers in 1, 2, and 3. But here we will not do that. What we'll do, only for 1 we will update the frequency to 1. That is, we are doing incrementing it by 1. For next, that is for 3 we are not doing anything, for 2 we are not doing anything. Directly the number after the last, that is after 3, what is the next element? 4. So for 4 we will go and reduce its frequency by 1. Why I am doing that, you will understand this, but just understand this point. Whichever is the last number in your range, go to the next number after the last number of the range. That is 3 plus 1. That's what I am doing. The last number, that is one number after your last number, that is 3 plus 1, and decrease its frequency by 1. Okay, so it will basically look something like this after all these operations. Okay, something like this. So for 1, that is, what is 1 is the number 1 is the starting, that is a from and 2 of the frequency, right? So this is the from. Here I have made it 1, and 3 is the last, that is the 2, that is from and 2, right? From is 1, 2 is 3. So here this is 3. uh, the element to the next of the from, that is index 4, there I'm putting a -1 there. Now how to get my real answer? So at last, this is for just one query. Like this, you have to process all the queries, and at last what you have to do, at last, remember, only at last, not after every query, only after processing all the queries, that is after marking all these things like this, like this, for all the queries, for all the ranges, you will have to do this step only once. Okay, what is the step? After processing all such queries, take the prefix sum. That is, what will happen, see, this 0 will be added to this number. 0 plus 1 is 1, so it will remain 1 itself. Now this particular 1 will be added to this. Okay, so it will become 1. Okay, and so on. This will also become 1 after that. Okay, and so on. And finally this 1 will be added to this, so 1 minus 1 becomes 0. So this is going to be the final answer. And see, this is exactly correct, right? All the numbers which are, the frequencies of number 1, 2, and 3 are made as 1. Okay, as you can see. So this is the prefix sum. So if you see the processing, we are not going to every range. See, in the previous question what we did, for every range we are going basically, in manual updating the frequencies by 1, that is adding the frequency by 1. But here what we are doing, we are just marking, we are just doing 2 markings for each range, the from and the 2. We are just doing 2 markings for each range. At last we are just going to add O of n time, and we are doing a prefix sum, and we are getting the final frequencies, that is each element is present for how many times. So this is called the line sweep algorithm, and we are going to use that now. So how to do that, let us see first. So before that also, see, because as I mentioned, the last, that is after all the operations, the smallest element that you can get is minus 10 power 5. Why? You can do 0 minus 10 power 5, which is k student power, right? So we're going to minus 10 power 5. Similarly, the biggest element that you are going to get is, okay, see, the nums of I can be 10 power 5, k also can be 10 power 5. So 10 power 5 plus 10 power 5, you are going to get the range. Okay, so that's why the ranges are pretty huge. For that reason, what I'm taking, I am based on the input, I'm going to take this now. Okay, so let us say the minimum element present in my nums array is some value. I'm doing a minus k for that. Okay, to get the smallest number that we can get. Okay, because like we have to press all such numbers, right? We have to mark the frequencies for all such numbers. So I'm just trying to get the smallest possible number. Okay, so I'm doing minimum of nums, that is the smallest element in my nums, and a minus k. This is going to be the min element. Then again I'm doing the same thing for max. I'm getting the max number, and I'm doing a plus k. Remember, here I'm doing plus. Just a second. Yeah, here I'm doing a plus, whereas here I'm doing a minus, because my, for taking minimum I need the minus, I need to do the minus. Okay, but for taking max I need to do the plus, because I want to see the max number that can come after all operations. Okay, so this is the min number after doing all operations. So this is the min element, and this is the max element. Fine. So the frequency that I'm going to store is going to be for all numbers between these two. Okay, so I'm going to go into the range, that is, see, for example, let's say min element is -5, max element is 5. So from between -5 to 5, there are around 10 elements. For all 10 of them, I am going to create a position, that is this particular array that I'm going to create is going to be this many, going to have this many elements. Okay, that is from -5 to 5, that is 10 elements, that is 0 to 10, it is going to have elements. Okay, 0 to 9. So it will create a frequency matrix, okay, whose length is going to be this. Okay, the range between them is going to be the length of that. Okay, as simple as that. That is, the zeroth index will represent the min element. Okay, so let us say min element is -5, that means the zeroth element is going to represent the frequency of the -5th element. Okay, let me just zoom out and show you this first, how it looks. Okay, like I've not printed the output here, but yeah, I'll just print that and show it to you. I will just comment this part out and I will just print and show it to you. Okay, I have to comment this part also. Yep. So yeah, as you can see, like the first, okay, let us go to some other case. Yeah, as you can see, here k is 10, right? What will happen? So the minimum element is going to be -9 here. So that means this particular element is going to represent, that is first, that zeroth element in my this particular array, okay, frequency array, is going to represent -9. The second, that is index number 1, is going to represent -8. The index that is the index 2 is going to represent -7, and so on. So this basically are going to represent the frequency of those numbers. Okay, as simple as that. That's what I wanted to show you. Initially all the frequencies will be 0. Next, what I'm going to do, I'm going through each of my numbers. Okay, now I'm going to start the line sweep algorithm. Remember that. So this is going to be the 2 range, and this, so from and to. Okay, so I is the from and j is the to range. Okay, from and to. So that is between all elements between I and j needs to be incremented by 1. Okay, the frequency for all of the elements between I and j, we have to increment their frequencies by 1. Okay, as simple as that. Nums, I'm doing number minus k, this is the number plus k. Okay, so all the elements between this range should have that we should add 1 to their frequencies, existing frequencies. So now I'm, this is the where I'm using the line sweep algorithm. Okay, exactly same part what I've done it here. Okay, so for the first thing, that is, yeah, for the I, remember, see, one more thing that I want to tell you is that, just a second. Yeah, so see here, as I mentioned, this zeroth element in this is represented by min element. Okay, then the, let's say -5, after then -4 is going to be represented by index number 1, and so on. Okay, so that's why I'm doing I minus min element. Okay, this will basically tell me for where, which index is going to store the frequency of this. Okay, I have to go to that index and do a +1 here. Okay, as similar as that. Similarly, for this is the remember in the lines of algorithm what we are doing. See, for the last element, we have to do a +1, and then we have to reduce the frequency by 1. Okay, same thing I'm going to do. I'm doing j, and then I'm doing a +1. Okay, and then see, minus element always you have to do, because remember the zeroth element, zeroth index is represented by min element. So in order to know which index is going to represent the frequency of this, you have to do separate from minus element. Okay, so this basically will tell me the index in which I have to go and reduce its frequency by 1. Okay, as simple as that. Like this, I will keep processing for all the queries. Once I process for all the queries, I'm just printing it. Okay, I'm printing the frequencies at last. Okay, yeah, I'm then starting the prefix sum. Okay, prefix sum starting from the index number 1. Okay, for that reason, the frequency of 0, I'm just storing it in the answer. Okay, the answer is going to max value of frequency of 0 or 0, whichever is maximum, to store that. Okay, as simple as that. Then I'm starting from the index sum of 1 onwards. Okay, what I'm doing for that is this is a prefix sum. Okay, this is basically the prefix sum of what we are doing for each element. Okay, take the value of its previous element and add it to current element. Okay, as simple as that. So what I'm doing, frequency of I is equal to frequency of I plus frequency of I minus 1. Okay, as simple as that. Frequency of I is equal to frequency of I plus frequency of I minus 1. And then if let's just compare whether we have reached a maximum value or not, we have to just compare and we have to store it here. Okay, as simple as that. For each new value, we are just checking whether we have seen similar value or this is the first time we're seeing this value, and we are storing it in the answer if it is a bigger one. Okay, then I'm printing this value and then I'm written the answer. Let me quickly show you the output now so that you will now be able to understand this. Okay, yeah. So basically, like this is how it will look initially. So if you see here, 4 is marked here and -4 is marked here. Okay, as simple as that. Yeah. So basically, the frequency is, see, for 1, the frequency is going to be 4. So, but remember, if you, yeah, see, this is going to the min element in this case. Why? Remember, 1 minus 10 is going to be -9, right? So this basically represents the frequency of -9. Okay, and similarly, the the other value. Okay, yeah. Remember, 1 plus 10 is going to be 11. Okay, so for 11, remember, 1 plus 10 is 11. So even for 11, the frequency has to be 4. But what we'll do, because we are using line sweep algorithm, so initially it will not be appearing like that. Okay, what we have to do, we have to go to the 12th one, that's the frequency representing 12. There you have to add a -4. Okay, as simple as that. Then when we do the prefix sum, this is how it will look. That is every number. Okay, for example, 1 minus 10 is 9, or -9. So from -9 till 1 plus 9, which is 11. So -9 till 11, all the numbers are going to have a frequency of 4. Okay, as simple as that. And now the max of them is again 4. So we have written 4 is the answer. Okay, as simple as that. So for that reason, if you see, because the algorithm basically needs this +1, right? This +1. For that reason, if you see, while calculating this range, what I've done an additional +1. Okay, this is not just a typo. This actually I have a real meaning of doing it, because I want to include the max element also. That's why I've done a +1. The other +1 is because our algorithm, the way we have designed it, it will be doing it like this. So always a +1 will happen. So even to include the last element, I have to add an additional element for this part. Okay, that's why this additional element is added. Okay, as simple as that. And if you talk about this, okay, as you can see, this is getting accepted. This is solution which can get accepted. The previous solution will fail. It will clear 95% of test cases, but it will fail after that. But this solution, it is around the best solution that you can get in this kind of question. If we discuss the space and time complexity, see here these two elements will play a big role in deciding space and time complexity. Okay, let's try to understand this space in terms of that. So see, if you talk about this loop, there is going to be O of n. So that is why we have n here in our time complexity. And after that, if you see, we are going to process this. Okay, this the element that we have created. Okay, we are going to all elements of this. So actually, the time complexity is going to be n plus max element minus min element. Okay, that is the total range that you are going to get. Okay, so what is max element? Max element is basically the max element here plus k, and similarly the min element is going to be the min element present in the nums minus k. Okay, as simple as that. So this will tell me the time complexity. Okay, other than that, if you talk about the space complexity, remember, only this particular thing consumes the space complexity. So the space complexity is going to be O of max element minus min element. Okay, this will tell me the space complexity of this. Okay, as simple as that. But yeah, on a whole, if you try to talk about the space and time complexity, both are going to be around O of n only. Remember that part, because if you see here, basically what can happen in the worst case. See here, see, as I mentioned, the range is going to be from minus 10 power 5 to 2 into 10 power 5. Okay, but since like these are like multiples of 10 power 5 only, because this is the range. Okay, n. So ultimately it is going to be minus n till 2 into n. Okay, that is totally processing will be obviously multiple of n only. So you can safely assume that both the space and time complexity are going to be in the range of O of n only. Okay, both of them. Okay, in the worst case, I'm telling you. Okay, so yeah, that was all this solution about. Okay, so I hope you enjoyed my video. Yesterday also we had a very good question. If you have not seen, again, please, it's my request, go and check that out. I've given a lot of efforts in that to explain the best solution, even better than the lead code solution that I have given for that question. Okay, I've made a lot of efforts to explain the best solution. Other than that, even in today's question, this is the opportunity for us to learn a new algorithm called the line sweep algorithm. As I mentioned, there was a bi-weekly contest in which this algorithm was asked, basically. Okay, in the that is question number 3, because question number 3 is basically the medium to hard level question. Remember that. In that, the similar algorithm was asked. Okay, question on the same algorithm. So this is a very important part if you have to solve questions on ranges. So this will play a very important role in that. So please learn this algorithm. I have given you a hint of how it works. If you want, you can go do a Google search and learn more about it. See, what I've teach is exactly what you need to solve this question. But yeah, you can spend some more time. Just as for example, I have shown only one query. You can see, like, if there are multiple queries, how this will work, and at last why, after doing the prefix sum, all the things are coming into place. You have to learn that. Okay, just take a pen and paper and draw and do that out. Okay, I cannot do all of this because I have a limited time to make this video. I'm not doing all the calculations here. Just take your time, do that for yourself. I'm sure you will get it, because in this video I want to just show you the seeds. Once you have the seeds, you can grow the plant on your own. That is the basic idea. I want to give you some resources, but you will have, it's your responsibility to build on those resources. Okay, as simple as that. So yeah, friend, that was all for this video. I hope you enjoyed this video. I'm putting a lot of efforts in trying to make the quality content available to you in free. Okay, if you like my resources, if you like my teaching, if you learn anything from my teaching, please consider subscribing to my channel, because this really gives a lot of motivation to continue further. So I hope you enjoyed it. See you tomorrow. Thanks a lot. Please like the channel. See you tomorrow.